Hi, I'm Don.
And I'm Will, and here's our standing meter.
So essentially, our question for our experiment is to find out how much we're standing in comparison to how much we're sitting down. It's kind of known that most people sit down more versus standing, but we kind of want to see a ratio of how much more do we really sit in comparison to standing. It's sort of linked to bad health if you sit more. So if Will and I find out that we sit a lot more, substantially more than standing, we might change our habits. And we're going to use this accelerometer to measure acceleration values of our legs in X, Y, and Z. And from there we can tell if we're standing or sitting.
All right, let's take a look inside of our box here. So we've got our Arduino screwed to the roof and our circuit down below. Here we have our accelerometer oriented to the bottom so we can get the data of our leg. We've got a battery here going into our Arduino, and we've got the Arduino hooked up to the SD shield and an LED over here that'll blink every 10 seconds.
Let's take a look at our FritzSync schematic. So we have our 9 volts battery going into our input voltage and a ground of the Arduino Uno. We also have our X, Y, and Z outputs of the accelerometer wired up to our analog inputs of 0, 1, and 2 of the Arduino Uno. And we also have capacitors here that are in parallel with the outputs of the accelerometer in order to just smooth out our data. And here on the left side of the breadboard we have an SD card that is wired up to digital output of the Arduino Uno, and then we have a little LED and a resistor that essentially blinks whenever the whenever the SD card is taking data.
So here's our Arduino code. It's pretty simple. We've got our board set up here that does the serial begin, make sure it's reading, does some pin mode stuff. Here we've got pin mode 7 output digital write high that makes sure our accelerometer isn't in sleep mode, and that it'll take data. Here's our loop. It's pretty easy. We're collecting the time from when it turns on, and we're writing out to this file here. We've got ADAT4. It's our 4th run. Here is just a simple reading in the data, and then we've got this calibration we got by measuring the max and min values, just sort of from flipping it upside down or not. So you kind of get 9.8, negative 9.8. And then here's just writing to the file here with our comma separated values. And we've got the digital write 5 high and low that flashes the LED when it's taking the data, and then it waits 10 seconds. So here's Don with our accelerometer in action. So as he walks, right, we'll have our X directions pointing downward. It'll be measuring negative 9.8. So when he walks, maybe it'll vary around then. We also have our Z direction, which is pointing out of his leg, which should be measuring about 0, maybe something else about that. So here's Don sitting down, wearing our accelerometer here. Because of the orientation of the accelerometer in the box, we have our X and our Y, which are both reading about 0. And the Z...
This is Will taking accelerometer data, going down the stairs in Baker's. Da-da-da.
So for the data analysis, I used Python on my computer. I just, grabbed the data from the SD card, brought it in here. I did a quick little function here just to average the data with its 2 neighbors, so we can kind of smooth out the data a bit, make it a little easier to look at. Here's just importing the data, setting some values, and then we get down here to plotting the data. Let's take a look at maybe our first data set. Here you can kind of see I put it on, as I walked home. Maybe there's some issues, but here I'm sitting down here, it's near 0. Maybe I'm jiggling around and stuff like that. I get up here to maybe do something, probably go to the bathroom, maybe over here I make some food, turn it off for the night, comes back on. This is definitely me walking to school and turning it off when I get to lab. So here's some analysis of our data here. We've got, looking at data set 3 here, you can see, data going up and down. It's important to note that when it's sitting, it's near 0 up here, and then when you're standing or some sort of motion, it's down near minus 9.8. So I wrote a little function here that just checks each data point, says, hey, is it less than -6, which will be somewhere in here, a good checking point, and then if it is, it says you're standing, and if it's not, it'll say, hey, you're sitting. So then down here we can look at the values, and then I converted them into percentages of the total time. So the first 2 points here are me, that's data points of me. So the first day I was sitting 87% of the time, and then the second time I was sitting 84% of the time. And here we have Don's data. He was a bit more active than me. He was sitting 75% of the time. So we can kind of see from our data that maybe I need to be a bit more active in my lifestyle.
And so do I.
So this project really kind of showed me that once you know how to work with the Arduino and the wiring and all that stuff, that it's really easy to just hook up a sensor or something, and it's kind of a really powerful way to get data of all these variables we have in our lives. And I thought that was a really cool thing you could do.
So in conclusion, this project was pretty cool. My partner and I, we came up with a question, something we wanted to measure, like something silly as even as standing versus sitting down, but we were able to hook up an accelerometer and code it to give us the data that we really wanted to, and have a time analog. So it's kind of cool that we were able to track our days and see what time we were walking and what time we were sitting. And I thought it was pretty cool. And also getting some experience with fritzing. It was pretty awesome that we were able to simulate the circuit on that program and see a schematic of it, and as well as using the laser cutter, being able to draw it and then just pressing start, and it would just print out this nice little box. So that was a pretty cool experience, and we're able to make like an object from our coding. So that was cool, and yeah, it was a good experience.